Welcome to Spring LIB.
Hello. Here we have to solve a task on the electrolysis of molten sodium chloride. The overall equation is shown here in the slide. So from 1 mole of sodium chloride, we can obtain 1 mole of sodium. Now let's answer the first question, which is, I presume, to find number of moles of electrons. In order to calculate it, we have to write down first the half reaction of sodium reduction. So sodium plus receives 1 electron and is reduced to sodium 0. Therefore, the number of moles of electrons required to complete this process equals to the number of moles of sodium formed as a result, which is mass of obtained sodium divided by the molar mass of sodium metal. So, or it is 215 grams divided by 23 grams per mole, which equals to 9.35 moles. Second question is to find the charge which is required to perform this hydrolysis. Charge equals to the number of moles of electrons multiplied by the Faraday constant, or 9.35 moles of electrons multiplied by 96,500 coulombs per mole. So the charge equals to the following. And this number can be rounded to 902,000 of coulombs. So the last question is to find the current which passes through the system during 96 and during 9.5 hours. So time equals to 9.5 hours, and we need to find the current. Current equals to charge divided by the time. And here we need to keep in mind that the charge has to be in coulombs and time has to be in seconds. That's why current equals to the charge divided by 9.50 multiplied by 3600, and multiplication by 3600 is required to convert hours to seconds, or it equals to 26.4 amperes. So now let's summarize our results. So the answer is the following. Number of moles of electrons is 9.35 moles. Charge equals to the following. So it's 902,000 coulombs, and the current equals to 26.4 amperes.